Welcome to BKW Physics. I'm Mr. McConnelly, and today we're going to talk a little bit about quantum theory. Now, the word quantum usually scares people. It sounds really intimidating. People don't know what it means. They know it's a high level of physics, and they're like, "Wow, that sounds scary. And I don't know if I can understand it." It's really not that bad. Let me break down some of the main parts for you. In 1926, Erwin Schrödinger started really dealing with quantum theory. He was one of the first people. And he said, matter acts like a wave and a particle. So sometimes when you look at, say, an electron, it'll act just like what you would expect a wave to act like. And sometimes when you look at an electron, it acts just like how you think a particle would act. And we're going to get into that more when we watch the Dr. Quantum video, which I recommend anyone watching the video also check that out. It's on YouTube. But that's the first thing he said. It acts like a wave and a particle matter. He also said it's impossible to know both the position and the momentum of an electron at the same time. So in other words, he said, if you're trying to figure out the position of an electron, you go like, there it is, and you find the position, then you can't know the momentum. And conversely, if you find out the momentum, like, oh, it's got this much momentum, then you have no idea where it's located. So you can only know one of those at a time. It's kind of weird. Now the next thing is the quantum model. The quantum model actually helps you address this, the position. It says, okay, there's a probability that an electron is in a specific location. And this is what you're used to dealing with when you were in chemistry. Because in chemistry you talked about, how did you talk about electrons? You said, oh, they're located in
shells.
Shells. Okay, that's one word for it. They're located in shells, orbitals. And so you said, well, I know that the electron's kind of in this shell or this orbital. And what the quantum model says is these are waves of probability. It's probable that the electron is in this shell right now. In those regions, we also use the term electron cloud. Okay? So, again, it's not real specific. It's not like you can say the electron's right here right now, but you could say, oh, it's in this cloud, this shell, this orbital. That's the quantum model. And everything is based on the quantum model about a probability. It's fairly likely this, it's fairly likely you'll find it here. The last thing is quantum mechanics, which is a whole study in physics. You could be a physics major, and one of your main focuses could be quantum mechanics. And if you are doing that, you're studying the property of matter using wave properties. So you're looking at matter, and you're saying, okay, let's apply wave properties to matter. Now, just as thinking of the word quantum, when you quantize something, what are you doing to it? You're putting it in groups. I don't know if you know that word in the English language. When you quantize something, you're grouping it. So if you're talking about quantum mechanics, you're grouping it into these probability bunches. Like, oh, the electron's kind of here. Probability to group quantum mechanics. Now, what this led to is the development of laser light, and in the future probably will lead to a lot of other areas of physics. But at this point, we're going to cut the video. As a class, we're going to go watch Dr. Quantum, and I hope that you do the same. Physics.